Hi, I'm Xin. This is my project workshop video for the project called ML Flow Switch Orchestrator. So basically, it is a lightweight machine learning control panel that can support most of the machine learning engineer life cycles. So I built it to show how trainings, model tracking, uh, promotions of the deployed models, and serving can all work together in like one flow instead of living as a separate scripts. So the main problems that this project trying to solve is it's more like operational, so not just modeling trainings. So I basically want to be able to set up a way to launch training from a spec, keep the training runs tied to a registered model version on MLflow, and be able to promote a new trained models without changing the public inference point. So the goal here is to make the full path from training to deployment in a more controlled and easier to reason ways. So the so this kind of problem often come up in my work with recommendation system also. So for instance, um, when we need to for recommendation model, it often requires retraining on a daily or weekly basis. So we need to have a simple. It's really beneficial to be able to set up a simple ways to be able to run the training in the background and let it automatically change the inference endpoint without affecting the production. So that's the main, and this project is trying to mimic that. So how the system works is pretty simple. It has four components: a router, which accepts the request from the user, MLflow, a backend which is used to store the model and the experiments, and serving and training images, which are provided by the user to host the training and serving environment and be able to replicate the training runs, and with a simple lightweight caddy proxy to provide a stable inference point. So I have made this mermaid graph on GitHub, so it's easier to visualize it. As you can see here, so when the user requests, such as I could just call it train or trains and row request coming, and with a spec provided, the control panel going to create a Docker containers that basically just going to run the training runs in the background. After the run complete, it will store all of the result into all the result into the ML flow to process it, and after which it will perform the health check as well as additional checking just to make sure the deployed inference point is stable. After which it will perform the rollout, which allows a zero downtime inference with the new models. Um, so. I have a demos already set up locally. So this is just the Docker desktop of how things run. So I'll see proxy, ML flow, and so here is the serving Docker containers that I already created. And I have this endpoint called status that just you can view the stats. So the current models deployed on it is version 12. And then you can run so you can also call the inference as getting your results. And you can I also created endpoints that allows you to, as you can see, it start a Docker image, which just to train the models. After training, it will, after it perform a health check, it will generally just going to replace the models, the currently deployed model at the end. So some of the key decision choices, I made it specifically so it's framework agnostic. So you can have a Docker, you can train a Skyler image, Skyler model or a PyTorch model or whatever model. It fully depends on what's all the Docker image you provided. All the training and serving runtimes are based on spec-driven parameters. Also, MLflow is served as a single source of truth for the lineage and register. Some other key decision choice is that I also added health-gated rollout, stable inference point, and rollback. So even if you the new model come up, right, it's not going to affect the production inference point. So some of the trade-off for future works, um, so everything on local, right? Currently everything on local, so it's kind of hard to in the future. I'm thinking of extending it to cloud using AWS. Also, a lot of the admin APIs or synchronous, right? So asynchronous job would be the next step. Um, the rollbacks track the previous deployment. Also, it's only blue-green deployments only, so there's no regression test. I'm also considering to add more integration tests and remote backends to strengthen it further. Yep. So that's all.